Good morning, my dear children. Today we are going to discuss about that interhalogen compounds and what are the properties of interhalogen compounds. Unit number 3, P block element 2.
Interhalogen compounds. Interhalogen compounds. What is about the interhalogen compounds? That's each halogens. It may be a fluorine, maybe a chlorine, maybe an iodine or bromine. Each halogen combines with other halogen. This one of the halogen, maybe chlorine combines with another one fluorine. Bromine combines with other one fluorine. Iodine combines with other one fluorine. Maybe bromine with the chlorine. Iodine with the chlorine. Iodine with the bromine. These are all. One of the halogen combines with other halogen. Am I right? One halogen combines with other halogen. We get is a series of compounds, of a lot of compounds. Many form of series of compounds that we are saying interhalogen compounds. Whenever we are going to write one interhalogen compounds, you have to write interhalogen compounds of a given compound. One of the compound A is less electronegative than B. First, you have to write which halogen have the high atomic number. That we have to write first. For example, it is only for an example. What is the atomic number of chlorine? 17. What is the atomic number of fluorine? 9. Am I right? So as we are comparing, which one have the high atomic number? Chlorine. So you have to write first chlorine, Cl. Next F. Okay. Which have the high atomic number? That you have to write first. When we are comparing bromine and fluorine. Bromine atomic number 35. Fluorine 9. So which one you have to write first? Bromine. Br. Brf. Okay. So such a way you have to learn practice. Okay. Here we have 4 types of interhalogen compounds. One is about that AB type, AB3 type, AB5 type, AB7 type. What are the different types? AB, AB3, AB5, AB7. Am I right? AB means they have a single atom. A also having single, B also having single. For example, CLF, BRF, IF, BRCL, ICL, IBR. These are all single atom. Am I right? This we are saying AB. What about the AB3? A have a single atom, B have a 3 atom. Am I right? CLF3, BRF3, IF3, ICL3. These are all what? AB3 type. What about the AB5 type? A means single atom, B means 5. Am I right? So IF5, BRF5. Can you understand, my dear children? AB7 means IF7. These are some of the examples. One of the very important 2-mark question. Try to learn this one. Next about what are the properties of interhalogen compounds. Some of the properties. What are the properties of interhalogen compounds? I think that we have more than 5 or 6 points. So try to learn this one, okay? At least you have to learn 5 points. What are the properties of interhalogen compound? The first one. The central atom will be the larger one. The central atom will be the larger one. That is the first property. Second one, it can be formed only between 2 halogen. Not more than 2 halogen. Two halogen means we can be say, for example, ClF. How much halogen having? 2. ClF3. How much halogen having? 2. So, it can be formed only between 2 halogen, not more than 2 halogen. That's the point. Can you understand? Next one. Fluorine cannot act as a central metal, being the smallest one, because fluorine have the lowest atomic number as we are comparing other halogen. So, fluorine cannot act as the central metal atom. Okay. Fourth point. Due to the high electronegativity with the small size of the fluorine helps to the central atom to attain the high coordination number. Due to high electronegativity with the small size of the fluorine helps the central atom to attain high coordination number. We know that the small fluorine have the small size of an atom. Am I right? Fluorine is one of the small size in halogen family. Here, small size helps the central atom to attain, it have a high coordination number. Next about, they can undergo the auto-ionization process automatically. For example, we are taking ICl, iodine chlorine, undergoes auto-ionization, that is forming an ions. One is about the plus charge and another one is minus charge. ICl is converted into I++, ICl2 minus. So how much chlorine there? 2 chlorine, so make it the reactant side 2. This is both forward and backward reaction. Same like that ICl3, forward and backward reaction. ICl2 plus ICl4 minus. ICl2 plus ICl4 minus, forward and backward reaction. So how much chlorine is there? 6 chlorine. So make it the reactant side, make it 2 into 3 is equal to 6. They are strong reducing agent. Next about the reaction with alkali. Reaction with alkali. When alkali is heated, the larger halogen forms oxyhalogen and the smaller forms halide. Here, BrF5. This BrF5 on heated with one of an alkali, maybe sodium hydroxide or potassium hydroxide. I am taking one of the alkali. Simply I am writing OH minus. That means it refers to an alkali. BrF3. Can you say this is a which type? BrF5. BrF5. Which type? AX5 type. That is AB5 type. BrF5 gives 5F minus, because you have fluorine 5F minus plus BrO3 minus bromate ions. Here, this is one of the larger halogen. The larger halogen forms oxyhalogen, oxy. That is BrO3 minus. Next one, ICl gives the presence of OH minus ions. We get Cl minus plus OI minus hypoiodate ion. BrF5. That is about that we can be say AB type. Okay, already we learned that interhalogen compounds can be classified into AB, AB3, AB5 and AB7 type. Here AB5 types, that is about that BrF5. On reacts with alkali, we get F minus and BrO3 minus. I'm right here. Larger halogen and smaller halogen. Larger halogen means when we are comparing bromine and fluorine, the atomic number of bromine is 35 and the fluorine is 9. Which one is the larger? Bromine is the larger. So bromine forms oxyhalogen that we are saying bromate ion. Bromine's form, there is a larger halogen, forms oxyhalogen, bromate ion. And the smaller halogen, that is a fluorine, atomic number is 9. It forms fluoride ion. Otherwise, we can be say halide ion. Am I right? That is about the first equation. Second equation, that is about that ICl. ICl means AB type. Here also having iodine and chlorine. Iodine is a higher, larger halogen and Cl is the smaller halogen. Larger halogen iodine form OI minus, that is hypoiodate ion. Iodine forms, iodine one of the larger halogen, forms hypoiodide ion, and the smaller halogen chlorine forms chloride ion, halide ion. That is about that, the equation. Next about, we learn about the structure of interhalogen compounds. What is about the structure? According to the structure, that is VSEPR theory, valence shell electron pair repulsion theory. According to this theory, the type AX, AX3, AX5 and AX7 type, what is the structure? AX has the linear shape, linear structure. AX3 is the T-shaped structure, T-shaped. AX5 is a square pyramidal structure. AX7 is the pentagonal bipyramidal structure. How can you explain this structure? And how can we explain the hybridization? And how can we explain the bond pairs and the lone pairs? First about the AX is AB type. Otherwise we can be say AX type. For example, I am giving some of the examples about that CLF, BR, EF, IF, BR, CL, ICL, IBR. These are the AB type. Am I right? These are the examples. For example, I am taking the very good example is CLEF. CLEF. This is one of the molecule. CLEF. I am making one bond here. So this is the which shape, as per we can be say it is one of the linear shape. Am I right? How can we explain the linear shape? Suppose I am taking chlorine. 2 chlorine I am taking. All of you know that on halogen, what is the outermost shell containing electron in the halogen means? All of you know that on 7 electrons. So, one halogen having 7 electrons. 2 halogen means 7 into 2 is equal to 14 electrons. Am I right? 14 electrons. Out of these 14 electrons, I am making bond between 2 chlorine atom. 2 chlorine atom bond between 2 chlorine atom. One bond means it needs 2 electrons. So 14 minus 2 means we get remaining 12 electrons. So 12 electrons I am accommodating such a way like that. Chlorine, one side 2 electron. Second 2 electrons, second, third 2 electrons. So out of this 6 electron over, am I right? Then remaining 6 more electron, I am filling like that. 2 electrons, 2 electrons, 2 electrons. Okay. Now 6 plus 6, 12, 12 and this bond having 2 electrons. The 14 electrons is over. So here we can be tell about that one chlorine atom. Suppose I am taking one of the chlorine atom. How much bond pair? Suppose I am taking this of this chlorine atom. How much bond pair and how much lone pair? So this is the bond pair. Am I right? This bond. This is we are saying the bond pair. How much bond pair having? One bond pair. So this chlorine atom, how much lone pair having? This is one lone pair of electron. Other lone pair of electron, other lone pair of electron. So how much lone pair of electron? 2 lone pair of electron. Is there no? 2 lone pair of electron. Sorry, 3 lone pair of electron. So 1 plus 3 is equal to how much? 4. All of you know that one.
hybridization 2 means sp, 3 means sp2, 4 means sp3, 5 means sp3d, 6 means sp3d2, and 7 means sp3d3. These are the numbers, am I right? So number 4 means what is hybridization? sp3 hybridization. Next one is about that AX3 type. AX3 type I am taking here ClF3. So here having 4 halogens. So 4 halogen means one halogen atom having 7. So 7 3s are 7 4s are 28. Am I right? 28. 28 I am writing chlorine, fluorine, because here having 3 fluorine atom. 1 bond means 2 electron need. 2 bond means 4 electron. 3 bond means 6 electron need. Okay. I told that 28 is out of 28. 6. What's remaining? 22. I am accommodating the 22. First fluorine 1, 2, 3, 4, 5, 6. Next fluorine 7, 8, 9, 10, 11, 12. Next 13, 14, 15, 16, 17, 18. So remaining to 4 more. Am I right? So I am accommodating to chlorine, nearest to chlorine. So due to this here electron repulsion, we can be say like that. So the shape is some should be changed like that. We can be say like that, a T-shaped. Okay. Bend T shape. Okay, like that, a small bend like that. Okay, due to the electron repulsion, that is not in our textbook. So try to understand the concept. Okay, due to the electron repulsion is having a small change, angle will be changed. So it becomes just like T shape. Which shape? Now also we understand that one. This is which shape? T shape. So what is hybridization? We can find the hybridization. How much? For one I am taking 1 fluorine. Okay, 1 fluorine. We can be say for this molecule, this entire molecule, not 1 fluorine, the entire molecule, how much bond pair having here? 1, 2, 3. So 3 bond pair. Out of this 3 bond pair, alone we can be considered as a chlorine. So the central atom having chlorine. The central chlorine atom having how much lone pair of electron? 2 lone pair of electrons. So 3 bond pair and 2 lone pair. So if you are adding 3 plus 2, what is the number? 5. So 5 goes to which hybridization? sp3d hybridization. sp3d hybridization. Such a way you have to take written practice like that, AX5 and AX7. Okay.